Good afternoon, my name is Stan Forrester, and we're going to be talking about forces today. This is part one. I think there'll probably be 3 parts to this, but we want to make this in kind of digestible chunks. Okay, so here's basic idea. A force is a push or pull. Take your hand, put it on the table, and push downward. That push that you exert down on the table, that is a force. The force that you feel exerted by the table back up against your hand is well, we'll call that the normal force later because it's perpendicular or normal to that surface. That is also a force. Now we divide these into contact forces, which require some kind of physical contact, and non-contact forces, action at a distance, things that don't require physical contact. The gravitational force and the electromagnetic force are 2 of these. Keep in mind that the contact forces mostly arise from the electromagnetic force, okay? It just so happens that the electromagnetic force, let's say your hand, the electrons in the surface of your hand and the electrons in the surface of the table, they're the same charge, and so they're going to repel each other, okay? But they interact such that there's still positive and negative charges. It just turns out that the 2 objects, your hand and the surface of the table, have to be in such close proximity to begin feeling that electromagnetic repulsion that we understand it in our macroscopic world that the hand and the table, surface of the table, are in contact. Okay, so when we begin to talk about this inventory of forces that we have to consider, tensions, normal forces, frictional forces, things like that. These are all kind of derived from the electromagnetic force, but we consider them contact forces. Okay. Okay, we have 4 fundamental forces: gravitational force, the strong nuclear force, the weak nuclear force, and the electromagnetic force. We're really only going to deal with gravitation and electromagnetic force. It's easy to keep in mind, though, that the electric force, sometimes called the Coulomb force, and the magnetic force, those were united by a man named James Clerk Maxwell, and very recently, well, actually not in this century anymore. Okay, in the previous century, the weak nuclear force and the electromagnetic force, there was a theoretical framework that came out, and we figured out that those were actually aspects of the same thing called the electroweak force. Occasionally you'll hear something about grand unification, where we want to try to repeat this, where we've already united the electric and magnetic forces and the weak nuclear force, and we'd like to include the strong nuclear force and the gravitational force, but that's for later. Okay. Non-fundamental forces, that normal force that we've already talked about. Okay, frictional forces, things that oppose motion, tensions in a rope, and normal, or I'm not sure why that's actually listed. I'm sorry about that. All right. Okay, force is a vector quantity. In other words, it has a magnitude and a direction. All right, and so the length of it makes arrows are a great way of representing this. The length of your arrow is the magnitude, and the direction of the arrow can be, well, by the direction of the arrow. Please note that we have a 5 Newton force shown there and a 15 Newton force. 3 times that 5 Newton force is not equal to the 15 Newton force that you see. All right, if we were to look at this, place this head to tail, another one, 5 newtons, and then 5 newtons, they'd have the same magnitude, but they would be pointed in different directions. Okay, so let's get into this a little bit. We have our individual forces here. Let's say we have a tension force, 10 newtons to the right, and a 4 newton frictional force to the left. All right, and we're going to add those up. Remember, here's this Greek symbol, sigma. It just means add them all up. So here's this force. We're going to add those up. So we're going to arbitrarily assign this 10 is the positive direction, which means the 4 Newton force is in the negative direction. So 10 plus a negative 4, that's 6 newtons. Okay, so that's our net force. Okay. Here's another example where we have to figure out, what our net force is. Here we have 3 newtons and 4 newtons. Okay, our net force is going to be 5 newtons, okay, at, well, 63.9 something degrees, okay, which we're going to round up to 64 degrees. You might be a little curious about how we get that. Just real quick, remember we're going to use, for perpendicular forces or components, we're going to use the Pythagorean theorem to find out what the magnitude of the vector sum of those is. So we just take your y component, square it, add it to your x component, square it, and we take the square root of the whole thing. And 9 squared plus 16 squared is 25. Well, we know the square root of 25. That's just 5, right? And that's what we have over here. The direction is, we're going to take the inverse tangent of our y component over our x component. As a matter of fact, you might want to do that right now. Just take the inverse tangent of 3/4 on your calculator. If you end up with anything other than 63.9 something, or something that rounds up to 64, it means that you're not in degree mode. You're either in radian or gradient or something like that. Okay? So make sure that you're in the right mode. This is one of the easiest ways to lose points on an exam. All right. And we are done. We're going to wait for part 2.